Okay, let's talk about perimeter and area in the coordinate plane. So here's a typical problem. They said, draw the figure and find the area of the perimeter. So the first thing you're going to want to do is actually plot out those points and figure out what kind of shape you're dealing with. And then we're also going to have to think about, how do I find the length of that line since it's not given? And so there may or may not be a distance formula involved. And then you also have to determine what kind of shape it is in order to figure out what formula you need in order to determine the area. So first thing we're going to do here is just plot those points to figure out where they are. So we're plotting -2, 2, and 3, -1, and I need to make my pencil a little thicker. Oop, that's a little too big. Let's go maybe a little bit in between. So there and there. And then -3, 3, and 2, 4. And then we're gonna connect those up. So we have some kind of quadrilateral. I can't be sure what kind of quadrilateral just yet, so I'm gonna count the slope of each line, and then I'm gonna decide whether it's a parallelogram or not. So when I'm looking at, I'm gonna just start from, and I'm also gonna label these. So A is down here in the third quadrant, and then B is over in the fourth quadrant, and C is over here, and D is over there. So let's look at the slope from C to D. It looks like it goes up 1/3. And I'm also going to compare that up 1/3. What am I talking about? Up 1/5. Sorry. Okay, and then I'm going to look at the slope of the opposite side, A to B, that goes up 1/5 as well. So those two sides are parallel to each other. Then I'm going to check side AC. So from C to A, it looks like it goes down 5/1. And then I'm going to check from D to B, that looks like it goes down 5/1. So that tells me a couple of things. It tells me that opposite sides are parallel, but it also tells me, since I think about the slope 1/5 and -5, that those are right angles and those sides are perpendicular to each other. So I have 90-degree angles here. And I can also tell, because it's the same exact slope, that I actually have a square here. But if I didn't know that, I could definitely find the distance for each of those sides and see if they were equal. So either way, we need to do that. So I'm going to find the distance just between C and D. So remember the distance formula, it's basically comes from Pythagorean theorem. So we're going to take the difference in the x's. So there's a change of 5, so you can use the coordinates here and think of, so here I'll just write down the formula: x2 minus x1 squared plus y2 minus y1 squared. So that's the official formula. but I'm going to eyeball this a little bit. So to get from -3 to 2, that's going to be a change of 5 squared plus a change of 1 squared in the y direction. So my distance there is going to be 25 plus 1, so square root 26. And we could do a factor tree on 26. It's in order to see if we can break that down. However, I get 2 and 13, and so there's not any perfect squares in there as far as factors go. So our distance for those lengths is square root 26, and between AC and BD, it's also the same. So my perimeter is going to be 4 of those. So I'm just going to take 4 times square root of 26. You could also do square root of 26 plus square root of 26 plus square root of 26 plus square root of 26, which would give you the exact same thing. Okay, and then the other part that we were asked to find was the area. And so we want to know, what is the area of the square? So if I'm trying to find area of the square, it's base times height, which in this case, they're the same, square root of 26 times square root of 26. So I could just write that as square root of 26 squared. So square and a square root undo each other, basically. So I get area is 26 units. In the next example, they want us to find the area and the perimeter again of a polygon, and there's only 3 points. I can sort of infer it's going to be a triangle, but let's plot those anyway. So the points are 0, 0 at the origin, and I'm just going to label these A, B, and C. And then point B is going to be at 3, 0, and then point C is at 0, -3. So our shape looks like that. Okay, so if we're gonna find, I'm gonna find the area first, because I know the area of a triangle is 1/2 base times height. And so my base here is just going to be the length of that side, which in this case, it's just 3. And then the height is over here because that's perpendicular to the base. So I know that's going to be the height, and I don't need to calculate anything. That's also a distance of 3. And I don't have to use the distance formula there because those sides are lined up directly on the coordinates and the lattice lines. Okay, so we basically have 1/2 3 times 3, so that's going to be 4.5 for area. And then I'm going to go ahead and find the perimeter. Now, we know that the base and the height are 3 already, so that part is fine. We just need to find this length here, that hypotenuse length, since it's a right triangle. And so we can find that distance D using the distance formula. So if I think about the change in x that's happening over that period, it's going from 0 to 3. So the change in x is 3 plus the change in y. So that's going from -3 to 0. So that's 3. And so distance is going to be 9 plus 9, which is square root 18. And we can break down that 18 if I think about doing a factor tree, that's 9 times 2, and 9 is really just 3 squared. So our distance is going to be 3 square root 2. Now, that's not the final answer that they were asking for, right? They really wanted to know what's the perimeter. So now I'm going to add up all 3 sides of the triangle. We had 3 plus 3 plus 3 square root 2. Now when I'm adding these numbers here, I can add the 3 plus 3. Those are like terms. But I cannot add that with the 3 square root 2. Those are not like radicals with each other. So that square root 2 makes it so that I can't add it with the 6. But you can leave your answer like this, or you can find out what the decimal is. So I'm about to plug that into my calculator. So I've got 6 plus 3 square root 2. And so in my calculator, it's given me approximately 10.243 if you're interested in what that decimal is. So that's basically how you're going to find area or perimeter. In the coordinate plane, you're going to plot those points, see what kind of shape you have. You're going to use the distance formula if you need to calculate the distance of something. Or if it's an easy segment that's just horizontal or vertical, then you could just count the squares, certainly. And then after that, you're going to add all up the sides in order to find perimeter, or you're going to use the appropriate formula in order to find the height.